In this video, we're gonna look at the project setup. So that would include creating a template project in iDefine. The template project will then be used to create a new project. The template project is a standard iDefine project that contains all the standard typicals and function blocks. Then we'll look at importing additional typicals and function blocks that you may have used in the previous projects. And we'll also study the cause and effect and review what type of typicals we may need and assign those typicals to the IO list so that we could import cause and effect and client IO with all the typicals assigned. To create a new template, you need the template project file. It is an IPT file. So this could be created by exporting a standard iDefine project as an IPJ file and renaming it to IPT. If you already have an IPT file that has been supplied, place it in a folder called template projects in your install directory. Install directory for iDefine will typically be in Program Files, Trinity Integrated Systems, iDefine 16. Here we create a new folder with the name Project Templates and we copy the IPT file into the location. You would have to open iDefine again and click New Project. The first option is to select the template project. So you could see certified SRS that comes in by default and the other projects you added. In our case, we use the IDGES SAS RO1. This is the sample project we intend to demo today. Now we'll create a new project with this template project. So give it a name and select your desired location. Add a description, username and password. Now log into the project. This may take a few seconds. The first thing you would look to do having opened the template project is to review what typicals already exist in this project. Within this template project, we have typicals that are named SAI, SDI, where S stands for safety. Another terminology you would find is SUO for startup overrides, MOS for maintenance overrides. You would also have 2 out of 3, 2 out of n OTID typicals, and STV for shutdown valves, and preset interlock groups. Then we are going to import some function blocks and typicals that we have exported from the previous projects. Now go to the function block section and select import function blocks. This opens the import function blocks window. Here select the exported function blocks file and choose the function blocks that you intend to import into iDefine and say OK. You can see that all the function blocks are being imported. Similarly, we'll import all the typicals that are associated with those function blocks. So go to the typicals area and select import typicals. Select the exported typical file and choose the typicals that you intend to import into iDefine. Now say OK. You can see that all the typicals are being imported into iDefine. Now we will review the cause and effect that we have received for import. This is provided by the customer and it is in Excel format. It has all the tag names and logic matrix. Sometimes you may receive a cause and effect where inputs are empty because they have got a description and it is not important to enter tag names. In those cases, we will have to assign a tag name in those fields. You may have cause and effects which use characters that are not supported by iDefine, like a slash for a tag name. In those instances, you will have to replace the unsupported characters. And once you have done that, your tag names field is clear. Make sure that the input and output tags are correct for the convention that is allowed within iDefine. The next thing is, iDefine will want to know which typical the tag names would use, and based on those typicals, you may have to specify a parameter as a part of the typical. Suppose you have a transmitter that is an LTO1. You know it is a high trip or low trip because it is written somewhere in the description. But iDefine will want to know where is the LL trip in that typical. So we give a reference as LL trip to the tag name and specify a parameter for it. Similarly, in the next line of logic, you may have a high trip for the same tag. So we give a reference as HH trip to the tag name and also specify a parameter for it. So there is an extra field you may have to assign. That field will have the parameter names for each of the tags you want to import. The typical allocation for these tags can be done as a part of your IO list, so that you don't have to do the typical assignment while importing the cause and effect. While you are inside the cause and effect, it is useful to review what type of tags you have got and what typicals have you planned to allocate to each of them. If you look at the cause and effect we have received, it shows that some tags have resets and some have overrides. So we know at least you need two types of analog typicals. One where you may have the latch behavior with reset and one without that. You may also need a 2 out of 3 voted typical with reset and override. You can decide this just by looking at these fields. Some inputs don't have latch. This is because they are feedbacks or valve position feedbacks. So whenever you see inputs being used for permissive actions, they don't have resets because permissives are not for tripping and we don't need a latch to hold them. Then review the IO list and categorize the tags and look for the typicals in the template project and assign those typicals to the tags in the IO list. So this is the IO list we have received for the demo. You can see that most of the tags are assigned with appropriate typicals. But if you have an IO list without typicals, you will have to review and manually assign typicals to the tags. Even in this typical, the voted ABC tags used in the cause and effect are missing here, which will be added to the client IO list in the next video. Similarly, on the output side, we look at outputs which have latch, outputs which have reset, outputs which have feedbacks, and there are other outputs that don't have feedbacks. Some valve position fail monitoring. You will also have to look at the outputs and assign typicals that are available in your project. If you haven't got a typical that matches your requirement, then go for the closest match typical, duplicate that typical, and modify the functionality to suit your needs. While we do that, you could name it to something similar to original typical, just so you know it is derived from that typical. We continue looking into the symbols in the middle of the logic section. And you see that there's a lot of symbols C, T, O and P. If you think about it from a logic sense, you don't have to worry about how many symbols are being used. You only have to look at the action field at the top. If you look at the action field, you've got close for C, trip for T and open for O. How many symbols exists within a single column? That's what we are looking for. If there is just open for all the fields and close for all the fields, you could just name it as X in the logic sheet in place of the symbols to avoid confusion. Now we go to the notes section where you can look for any other information that may be provided. One of the main information that has not been provided in the main grid is how does it reset? What is a reset tag called? There are some clues for that in the notes section. You can see that a soft reset is to be provided for the system logic reset, and there is going to be a maintenance override, which is also a soft function. In some cases, you may see whether there is a requirement for maintenance override enable and so on. Now you know how to set up a project using template project and how to import function blocks and typicals into iDefine and how to review a cause and effect. In the next video, we look at how to add memory tags to cause and effect matrix and client IO, add area fields in client IO, preview typicals and import client IO into iDefine and import cause and effects into iDefine.